In this video, I'm going to talk about the derivatives of sum and differences of two functions, and then I will extend the idea to multiple functions, more than two. So let's start off with two functions, f of x and g of x. So my two functions are f of x and g of x. I would like to find the following derivatives. So the derivatives of f plus g of x, okay? Which, by the way, is f of x plus g of x. And let's call this new function to be my uppercase f of x. So finding the derivative of some of these functions is equivalent to finding the derivative of f of x, uppercase f of x. Now, using the definition, I'm going to have f prime of x is equal to limit h approaches 0, f of x plus h minus f of x, all of it, divided by h. So then I could write it as limit h approaches 0. Now f of x is equal to f of x, a lowercase f of x plus g of x, right? Now x plus h means I'm going to have to replace x by x plus h, and here x by x plus h, and here inside in g x by x plus h. So this is end up going to becoming f of x plus h plus g of x plus h. Let's put it inside a square bracket to separate things, minus f of x, which is just f of x plus g of x. So there's going to be minus f of x plus g of x divided by h. Limit h approaches 0. Now I could break it down into two pieces. Actually, I will just leave it as it is for now and then break it down later. So I could write it as f of x, okay, then plus g of x plus h minus g of x, and all of it divided by h. Now, if I break it down into two pieces, which I can, because limit of the sum is sum of the limits, so I'm going to distribute this h to this portion and this portion. Then I get this limit on the left, and on the right this limit. This, by the way, is nothing but f prime of x, this one, and this is nothing but g prime of x. So I just showed that derivative of f of x plus g of x, derivative of f of x plus g of x is nothing but f prime of x plus g prime of x. And similarly, we could show just by using the exact same argument and by changing the sign right here, okay, instead of positive, if I use negative, I can show that a derivative of f minus g of x, okay, is nothing but f prime of x minus g prime of x. Now this idea can be extended to, by the way, 3, 4, 5, 6 different functions. So for f plus g, you may not necessarily have to restrict it to 2. You can have another function h, and you can extend this idea. Prime of x is going to be f prime of x plus g prime of x plus h prime of x. And you can extend it to 4, 5, 6, or any fixed number of functions. Now, for the subtraction, maybe we could do something f minus g minus h, right? Let's say I want to find the prime of it. So that I could really write as f plus negative g plus negative h and prime of it, x. Okay, let me put an x here. And by converting the subtraction into addition, I can go ahead and apply this formula and do the find the derivative, and it'll work like the way we expect it to. So this derivative is gonna be f prime of x minus g prime of x minus h prime of x. Once again, you can extend this idea to arbitrary number of functions. So what did we learn? We learned that derivative of sum of functions is equal to the sum of the individual derivatives, and same holds for differences. I hope that this discussion was helpful. Thank you very much.